My name is Oliver Bochem and I'm presenting this project for Andreas Krause at ETH Zurich. So this topic is entitled Scaling Up by Scaling Down, and it's about large-scale machine learning. Now, having access to big data has many advantages in machine learning and allows us to train much nicer models. But it has a key drawback. Too much data can mean that it becomes computationally infeasible to train these models. For example, if we have 10 times as much data as we had before, we suddenly may have to spend 100 or 1,000 times the computational power to even train a model. Now, in this project, we try to address this problem. And what we want to do is we look at techniques to compress data down. So we take some large data set. This is shown here in the picture on the left. We have some huge data set, and we want to select a subset of the data which explains the data very well. And we want to do this with theoretical guarantees. For this, we look at a technique called coarse sets, and the goal is then to train a model on this small, compact representation of the original data, while retaining guarantees that the model trained on this small set is competitive or comparable to the model trained as if we would have used the full data set. Now this is shown here on the right-hand side. This is a mixture model that we trained on this particular data set. It will become possible to scale existing machine learning methods up to a big data setting. Now, we applied this to some simpler models in the past, and we want to go in this project to a variety of rich models, latent variable models, deep nets, and so on.